Hello, my name is Nazir Khan from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada, and for those viewers around the world, welcome to you also. What we are dealing with this problem, we're dealing with limits and radicals. So when we look at the problem on the screen, we have a fraction really, and that fraction has a radical in the denominator. So when we look at this, if we were to go and as x approaches 0, substitute 0 for x, especially in the denominator, you will see that this becomes 0, and a root of 9 will be positive 3. Minus 3, you have division by 0. So that means that we have to go and perform an operation more or less to eliminate that particular problem, division by 0. When we look at, let's review first of all a difference of squares. Now, a difference of squares is a binomial really, and when you look at the whole first term, it's squared, the whole second term is squared, and it has a minus sign in between it. Now, the factor of a difference of squares is what they call conjugate pairs. And when we look at conjugate pairs are two binomial with the same content. However, there is a difference in sign. One is going to be minus, one is going to be plus. Now when we look at this, how do we know that this is actually true, that conjugate pairs is the factor of a difference in square? We could just multiply it out. This time the first times the first will give you x squared. This times that will give you positive xy. Minus xy cancels out, and minus y times plus y will give you minus y squared. So we know that this is the factor of a difference in square. That's the technique we're going to use in here to eliminate the root sign in the bottom first of all. So let's go and create, I guess, conjugate pairs in the bottom. To do that, we're going to use equivalent fraction, the theory of equivalent fraction also. And let's go and set that up. As you can see, this part of it is basically repeated right here. But when we look at the denominator here, we have, we're going to make conjugate pairs of the denominator. We're going to have the same content, just the sign is going to be different. It's going to be a plus sign, just like we have in here. Okay? And then the numerator will be x times whatever. Once we multiply the numerator and denominator by the same term, we're keeping the same value. It's called equivalent fractions, and that's okay by mathematical terms. When we look at this now, the reason why we went and created conjugate pairs, because we want to go backwards. We want to go backwards to a difference square. Now, if I wanted to go backwards from a difference square from this, I just have to take the first term and square it, the second term and square it, put a minus sign in between it, and I've gone backwards. Let's go and look at that. If we were to do this, if I were to take this first term and square it, it would eliminate the radical sign. If I take the second term and square it, it'll become 9, and I put the minus sign, I would have gone backwards. Okay, let's do that. And of course, that's what I did here. Square this term, you get x plus 9. Square this term, you get 9. And you put the minus sign in between. These 9's cancel out, and you have x and x. And I've placed these in red because this is what happens in most cases with these type of problem. You are now going to cancel these out, because if you go and substitute 0 for this, you still have division by 0. So it has to cancel out. And when you cancel them out, the next step is to substitute the 0 for the x. Right? These canceled out. You're only left with the numerator, and then that gives you, under the radical sign, it'll give you 9, which is 3. Plus 3 will give you 6. And then you finish off the problem by just writing the original equal to the 6. And basically that's it. Right there. That's all there is to this problem. I hope that it helps you with your studies. Thank you. Bye-bye.